Hello, welcome to this part of our tutorial. Today we're going to look at how we can use the result of our tests, MAR, BHP and other tests to improve the overall performance of our model, to improve the calculation power, the prediction power or the forecasting power of our model. So we're going to go straight to the business of the day, but for the part we'll be developing the initial model. I'll be a bit fast in those areas. The reason being that I've covered that severally in my tutorials, so I'll concentrate more on the part we'll be doing the oil PVT matching. Okay, so let's continue. As usual, we're going to start with defining our model. So we're going to use oil, water and then black oil, so we'll leave the values at their default. So I'll quickly supply the PVT input parameters. For that we have a GOR of 845, oil gravity of 3.4, gas gravity of 0.71 and salinity is about 10,000. I have data of course for the matching, but I'm gonna copy that from a source and quickly copy and paste. Okay, so I'll go to clip and copy from clipboard. Yes. Okay, so from the data we know that our temperature is at 185 and the bubble point pressure is 1660. That's the data. So we're gonna go straight into the regression and then we match all. So let's look at the parameters for the matching. I'm gonna use standard deviation as my standard for choosing any of these parameters. So look at bubble points, no standard deviation, but we can look at the parameters 1 and 2. They should be close to 1 each. So we'll look at the Lasetta is the closest to 1 and it also has the least value of parameter 2. Okay, do we say the least or the highest? I think negative value is the larger the negative value, the smaller. But anyway, we're going to use Lasetta for bubble point. We also look at the GOR. We have Lasetta as giving us the least standard deviation, value for standard deviation, and oil formation volume factor. We have Vasquez. I think that's the least, and then no. Okay, yeah, for the Halmahon. But I'm gonna okay. So for this we should use Vasquez, but then you can only use one correlation for the first 3 values you have here for bubble point, GOR and oil formation volume factor. So if I choose this, then this will be greatly affected since it's higher than this and also higher than this, and then also the value here is also high. So I'll still stick to Lasetta, which is still giving me a pretty small value. Yeah, so I'll use Lasetta for the bubble point, GOR and oil formation volume factor. Then for the oil viscosity, I'll use I think VL et al is giving us the lowest, followed by Bex et al. So I'll use VL et al. So you can just come here and you choose your correlation. So I'm gonna use Lasetta for these and VL et al for this. You can also confirm the values from here. So if you change this to, let's say, standing, so the values here change, so you can choose them from here without having to go to the parameter section. So okay, that's all I got on PVT smashed, and then we can proceed. The step there is actually very important because the correlations you choose here will affect whatever prediction or forecasting or whatever results your model will give you. So these correlations are important. You should take time to match them so as to get an improved overall performance. Maybe I'll come back and maybe change these correlations later, then we can look at our results and see the effect it has. Okay, so let's go to this. I'll click on all, and as usual I'll be looking at the surface equipment in this tutorial. So what we have is a vertical well, so the surface from the surface down to the TVD, just 8,000 feet. And then we have SSV installed somewhere, and then we have tubing getting to a production zone, and then we have the casing, so which has been perforated. The casing is at TVT, and it's about 8.3. Okay, and the roughness factor is 0.0018. The tubing is 3.99, yeah, 3.992, and is installed at 7,800 feet. Our SSV is 2.2 inches, not feet, sorry, yeah, 2.2 inches. Okay, so we can go down the data here. Looks okay. For our temperature profile, we have 60 degrees on the surface, and activity we have 185, of course, from our matching result. Okay, from our lab result and all that. So we'll look at overall heat transfer. I'm going to start with 8 BTU per hour per feet square per Fahrenheit. So okay, and then I'll leave the heat capacities where they are. Okay, so we're good to go. So let's quickly use DASI for this, and then our reservoir pressure, initially what we have is about 2790. Temperature we know is 185. Our water code is at 0 at the moment. So we'll look at permeability. We have 800 millidasi, and the reservoir thickness is 800. Drainage area is about 340 acres. Pressure factor, our reservoir is at the center. We can calculate this from this. So we're going to look at the overall length and the width, and then you look at the distance to the other end and the distance to the top, so side and top. So if it's at the center, so once you supply these values, you can get what's the right one, but I'm not going to use that. So I have my values already. So we have this to be our roll bore radius to be 0.354 in feet. If you change that to inches, that should be about 4 point something, yeah, 4.248. So I'll leave it in feet. So you can always change the unit from here at any point in time. So maybe you want to look at the thickness in maybe meters, and that's what you have. So okay, so the next thing we have to do is to supply a skin. So we're starting with a value of 2. Of course, let's leave that at our absolute pump for potential. We have about 11,516. So let's note that value, and then our formation PI is 0.02. Okay, I'm gonna do something quickly, and then I'll come back. So I'll come here and I'll change this correlation to maybe less so, and let's quickly go back and calculate and see if we still get the same thing. Okay, so we had 11,516 initially, and now we have 11,529.8. okay, so you see the effect it has on our model. So you can also change this to some other one. Let's look at squares. I think this was also pretty close. Then we can also still calculate this again and see. So now we have 11,483 from initial value of 11,516. So like I said, whatever correlation you choose here will greatly affect your result. So now I'm using only the IPR to show the effect. Of course, it will definitely affect the VLP, and then it will affect the general matching all through. So you should take time to match whatever you have here and then to choose a good correlation. Okay, so let's quickly look at the system variables. We want to look at VLP and IPR intersection to see our flow rate, if it actually matches what we have in real life. So our top node pressure is at 250, water cut is still at 0, so we're not doing any sensitivity. I'll just calculate, and wow, it says our oil rate is at 5,262. That is low compared to what we have in real life, and of course that's the reason why we have to conduct this oil PVT matching. Okay, so you can actually get more details from this from here. So look at your pressure loss to due to skin. You look at a whole lot of things: gas, deviation factor, superficial velocities. What you can use this to calculate your flow regime, and then all that. So a lot of other details you can go, and then you can do your sensitivity, pressure versus depth or whatever, or other sensitivity. Okay, this is because I didn't input anything here, so where is that? Okay, I didn't specify values here, so if I choose any of this, maybe reservoir pressure and sensitize, that should work well. I'm not going to do this in this tutorial. I have that covered in other tutorials, or maybe I'll do a dedicated tutorial on that too. Okay, so now to the business of the day. The business of the day is how do you match? Now, I just observed that from our VLP IPR intersection, value we are getting is much less than what we have in real life. In fact, this is the test result in real life. So let me expand that a bit. So we have a liquid rate of 6,300 STP. So that's what we're gonna use to match. So let's quickly go. You can use the screen here. I can easily click on this VLP IPR matching, or you can go to calculation and you look at what is it again? What is it? Matching, sorry. You go to matching and test. Okay, so it brings us to the screen. This is where you actually do your matching. I'm gonna use liquid rates for the rate type, but you can use oil rates. I'm using liquid rate because that's easier to measure, since what you're getting from your reservoir is a mixture of oil, water, gas, and whatever you have. So it's easier for you to get this. Okay, so test dates. Any day. What was actually our test date? I think I have the data here, so I'll just keep this somewhere and then copy from there. Okay, so that was on the 13th of January. Okay, so I have. Would you come up and stay somewhere? 0113. Okay, 2023. That was last year, and it actually MER test for that year. MER test. MER is maximum efficiency rate. So these are tests conducted periodically, I think twice a year or so, to determine the maximum rates at which to efficiently produce from a reservoir, so that you can obtain the ultimate recovery. If you accept these rates, the effects might be that you might produce water early, or some other undesirable effects like some production and all that. So these tests are very important in order for you to produce long enough and to recover as much crude as you can without the onset of those production problems. So it's a good place to get your data. Your other tests are PHP test, bottom hole pressure, and others. So I look at the tubing head pressure information we're getting. I don't know. Okay, it's here already. A tubing head is at 250, and that's our top net pressure already, right? It's our top net pressure. Tubing head temperature, but what we're getting for temperature is 126. This value here will affect your what is it called again? Overall transfer coefficient. So you should be very careful whatever input here. Anyway, we'll look at that in a bit. So water cut is still at 0, and liquid rate is 6,300. So 6,300. The depth at which this measurement was taken is at 7,000, and the pressure is 1950. 7,000, and then we have 1950. Okay, the reservoir pressure from the PHP test that was conducted around that time is 2768.2. 2768.2. Okay, and then the GOR is 845, still at 845. That's good for us. 845, and then 845. I'm using 846. Okay, the GR free is at 0. Okay, now the recommended procedure is written here. It says first you estimate the U value, because the temperature will affect the PVT, of course, and then from there you do correlation comparison before you match your VLP. Then you do VLP IPR check, and then you can adjust your IPR if there is need. Okay, so those are the procedures. first we look at this, and it's saying our heat transfer coefficient is actually 7.8, not the 8 we're using. So it's asking if it should transfer. Of course do. Now let me show you what the effect is. If I change this to a value like 100 and I estimate this, it's giving a higher value. So that's why I said you should be careful whatever value you use there. It should actually be something you measure from the field, from a gauge, or from a meter, transmitter, whatever. Okay, so I'm gonna estimate that again and accept that. Okay, so now let's look at our correlation comparison. This is where it gets very, very, very interesting. Okay, so I'm gonna select all of them initially. Yes, I'll start with all of them initially, and then I'll calculate. Okay, it's saying license problems for some of those correlations. There's no problem. Okay, so I can plot. Let's just plot and see what we have. Okay, I think this is pretty smooth. From the results we're seeing here, we see a lot of these correlations do not. They will give us something lower than what we're expecting, and just one of them you'll over predict. Which one is this one? This screen is not showing everything. Okay, but just one of them is actually matching perfectly. I don't know how that happened to be, but I think it's actually something good for us. And this is Bex and Brills. Yeah, that's Bex and Brills. So Bex and Brills is giving us the perfect match. So since we have that, there's no need to stress ourselves. So we can just come here directly and unselect everything. Oh, sorry about that, and then just select Bex and Brills, and then we'll proceed with that for the rest of our simulation. Now, okay, I didn't plot that again, so let's just plot and see what we have. So that's that, Bex and Brills, perfect. Okay, now most times you'll have more than one test here, so it's good practice to disable other tests and to test them one by one. If you have a consistent result, then all the tests are good. If the results are not consistent, that means some tests are actually bad. Of course, it's possible to have bad test results depending on how the test was conducted, who conducted the test, and how diligent they were while they were conducting the test. So you can use this to actually know which test is bad, which test result is bad, and you can discard those from the good ones and then use the good ones for whatever you're doing, your prediction and all that. Okay, so for now I just have one test, that's why I'm using that, and I pray that the result I got here was actually correct. But for now we'll assume this test was performed diligently by the best hands, and then we had the best result. So that's. And then the next thing is to match our VLP. Now look at the, so I'm gonna do match. I'm using Bex and Brills because that's what gives us the best results, and this is what I have, and of course it's giving us the exact this thing. So the measured and the calculated, they are the same. So good for us. So I do done. So now let's go to VLP IPR check. This is, I think we'll do a bit of this thing here. So I'm gonna calculate, and after that let's look at the screen. It says the solution rate is 4,000 while our test rate is 6,300. The solution BOP is 2041 while our test PHP is 2022. So that means there's something wrong here. What we actually have to do is we've noticed that the problem is not actually from our VLP, since our VLP results give us an exact match, right? The match here was exact, while the VLP and IPR is giving us this discrepancy, meaning the discrepancy is actually coming from the IPR. That's why we have to get to the IPR screen and then do some checks, do some changing. So first, let me first change our pressure, reservoir pressure. What did we have again? We had 2768.2, 2768. So 2768.2. I'm gonna start with that. I'll calculate again, and then I'll come in, and then I'll calculate this again. Any improvement? Yeah, there is, but not very good. So we still have to go back and check. So meaning the pressure wasn't actually the problem. Let's look at our parameters now. Permeability is one of the values that is always prone to errors, since it's not very easy to calculate the permeability, especially as the rocks, the reservoir is not homogeneous, it's mostly heterogeneous. So getting the permeability of the individual regions is, and then using the average, you'll almost always get an error there. So let's increase that to about 150 and see if we get something better. So we'll come in. You can take note of these values, but for now not very important for me, so I'll come in and I'll calculate again, and this time around we have something better. So 5,000 and that. So you can continue playing around, but for me, you can also look at the skin. Skins, please. You can look at the skin. Let's look at 1.5 for the skin. Let's see, was that 1.25, and see what effects that will give us. So I'll calculate again, and I have 5,200. Okay, we're still getting there. So you can also look at I think this reservoir thickness, maybe it was a bit not very good prediction there. So I'll also do this and see what do I get. Yeah, okay, now this is pretty close, 6304 and 6,300. So, and then actually our PHP also is very good. So I think from there we can stop, or you can continue and adjusting your IPR data to see if you get something good. So I can plot these and I will look at the difference. The difference is about 0.06, which for me I can tolerate, but there are some people that will need something better than this. So you can continue adjusting your IPR until you get excuse me please, until you get what you're looking for. So I'll go main. Did I go main? I should. Let's look at something else. Okay, I think we are done with this. Let me calculate again. We are good, so I go done. You can also look at adjusting the IPR, but before we do that, oh, my screen is outside the region again. Okay, so I'm gonna select this tests. Let's just select that and then calculate for highlighted text. Okay, yeah. Okay, so we are having our this thing here, and this is actually the point we're expecting. So if you look at what is it again? Reservoir pressure 2768, and it's saying, is there any discrepancy? Solution flow bottom oil pressure is 21, and then what do we have here? Calculated flow bottom oil pressure is 1978, so that discrepancy is here, this and this. Then what again? Solution rate is 7,008, and what do we have? Our rate was actually 6,300. So you can adjust some things here. Let's see, let's try to adjust our pressure. Okay, so calculated reservoir pressure is actually saying the pressure should be 2454. But what we have 2768. So what do? Do we accept the results? I think with that we should be having something very close. 1979. Okay, 19. We have now something very close. So do we accept the results? Solution rate also is close, so I can accept the result and update the reservoir section. Okay, I can update both sections, so let's just accept the result. Okay, so you can also look at your APR data too, but I don't think. Let's just cancel this. Let's cancel that, and you calculate again. You should have something. Uh, very good. Okay, so we have 1979, for adjusted pressure, 2454K, then 6296 and 63. Those are pretty okay. Pretty okay. Okay, so that's how to do your matching. So when you come back, we're done with this section, so you can go back and predict these again and see what results you get. So and then calculate jar. So now we have 6287, pretty closer than what we had initially. We had about what do we have? I think it's about 5,262 or so. Yeah. Okay, so that's what you do. It's as simple as that, and that's how to do the matching. I think that's all for this tutorial. Okay, thank you very much for watching. I'm sorry for those who've contacted me. I've received a lot of requests and mails, chats and calls lately. Thank you very much for always watching the tutorial, and thank you for your questions, your suggestions and your input contributions. For those who've requested videos or help which I've not really had time to attend to, I'm sorry about that. I'll try my best to attend to your request. So thank you very much for all you've done. Do well to like, subscribe, and also push the notification button so as to get notified. I'll try to post more videos, especially in the first half of this year. So stay tuned.